Hi everybody, this is Mr. Avila back with another video on, in this case we're learning how to convert a polynomial from standard form to factor form, a cubic polynomial for this situation. We're talking about a situation where we're going to let h be a polynomial function where x where h of x is equal to 3x cubed plus 25x squared plus 42x minus 40. We're given one of the factors as x plus 4, and we're going to convert h of x to a product of linear factors, and we're going to use the factors to find the zeros of h. A lot going on here, very difficult problem, I have a lot of work to do here. So we're going to first take this polynomial that's in standard form, convert it to factor form, and we know one of the factors is x plus 4. So we're going to set it up in what I call the Avila box, and we're going to use the Avila box to write our standard form polynomial in here and the factor we're given. So the factor we're given is x plus 4, and we are given the polynomial 3x cubed plus 25x squared, little small there, 25x squared, plus 42x, and then the minus 40 at the end. Okay, so these two are going to be combined with this circle, combines with these two terms. This circle combines with these two terms. So we need to find the missing part. X times what gives me 3x cubed? That'll be 3x squared. That's going to help us find this missing box. 3x squared times 4 is 12x squared. Now that we have the 12x squared, and we know it, we have to add with this one to give us the 25, then this one must be 13x squared. 12 plus 13 is 25, gives us that number in the middle. Now that we have this 13, and we know we're multiplying by x, then this has to be 13x, because x times 13x is 13x squared. And little by little, we were able to piece together the whole thing. 13x and times 4, 13 times 4 is 52, so here we get 52x. So we're almost done with the box, we just have 2 more spots left here. Now 4 times what gives me negative 40, that'll be negative 10. That makes sense because if I multiply x times negative 10, I get negative 10x. And if I combine 52x minus 10x, that gives me the 42 in that spot. Looks good. So we've converted into, we've factored so far. So we took that 3x cubed plus 25x squared plus 42x minus 40, and we converted it into factor form almost, but it's just not in all linear factors. X plus 4, which was this one right here, and then the top part that we found, 3x squared plus 13x minus 10. But we're not done yet because we haven't converted into all linear factors. This is a linear factor, but this is as a power of 2. This is not linear. So we have to take this and convert that into factored form with a smaller version of the Avila box, the one that we learned at first. Boom, boom, we put this Avila box, and we set our standard form, 3x squared plus 13x minus 10. Take that into the Avila box, and we start factoring. The factors of 3x squared are just 3x times x. I need 2 factors that multiply to give me negative 10 with a 13 in the middle. So it could be 10 times 1 or 5 times 2. Don't forget we have to get a negative 10. Now the one that works here, 5 times, I think it's 5 times 2. So we're going to put a 5 here. No, wait, 5. Yeah, 5 times 2. We're going to put a positive 5 here. And then a negative 2 here. Now for sure that gives me negative 5 times 2 gives you that negative 10. 3 times 5 is 15. X times negative 2 is negative 2x. 15 minus 2 is 13. Boom, we got it. We've now converted that into linear factors. We end up with 3x plus 4 times the 2 factors we just found for this one. 3x minus 2 and x plus 5 on the top. So we converted this into 3 linear factors. Now we're curious to know what the zeros are going to be. Now if we have a function in factored form, the zeros are very easy to find. The first one and the second one are pretty easy. X equals negative 4 is one of them, just the opposite of what you see there. And the other one is x equals negative 5. We found 2 of the zeros. The other one is the opposite of this sign, which is going to be positive. And then you take this number 2 and divide it by 3. That'll give us the other 0, 2 over 3. Okay, so we took a polynomial, converted it into a factored form of 3 linear factors, and we use those factors to find the zeros. Pretty heavy problem. Let me know if you have any questions. Thanks for watching. See you in the next one.